Troubleshooting water heaters often involves addressing issues with the overload cutout popping out and the upper thermostat. There are common causes for this symptom, including firstly, a thermostat stuck in the closed position, secondly, a shorted heating element, and thirdly, thick sludge accumulated around the upper thermostat. When addressing such problems, several troubleshooting steps can be taken. 1. Check the heating elements. Measure the resistance between the terminals on both elements. A typical reading should be around 13.5 ohms. It is also important to check for shorts to ground using a high resistance ohm meter, which should ideally read infinite ohms, indicating no continuity to ground. 2. Check the thermostats. Use an ohm meter to check continuity between the terminals. Turning the set screws back and forth should cause the thermostats to switch on and off, confirming their proper function. 3. Examine the wiring. Ensure that the upper thermostat wire is connected to the upper element terminal and the lower thermostat wire is connected to the lower element terminal. Reversed wiring can cause continuous power to the upper element, which will trigger the overload cutout. If the electrical checks appear normal, it is likely that sludge has accumulated around the upper thermostat. This sludge can cause the thermostat to stick, preventing it from shutting off power to the element. This situation leads to overheating and the subsequent activation of the overload cutout. Consider a scenario where an electrician is called to inspect a water heater exhibiting this problem. Initially, resistance checks between the terminals on both elements reveal a reading of approximately 13.5 ohms each. Furthermore, checks from the elements to ground, using a high resistance ohm meter, indicate no shorts. The thermostats are then tested by turning the set screws back and forth to ensure they are switching on and off correctly. These tests also show normal operation. However, upon closer inspection while adjusting the upper thermostat, it is observed that the element becomes energized when the set screw is turned counterclockwise. Although the initial focus is on the thermostat switching between the two terminal screws, the underlying issue lies in the wiring configuration. Specifically, the upper thermostat wire has been inadvertently connected to where the lower thermostat wire should be, and vice versa. When the wiring is reversed in this manner, the upper element receives continuous power. Consequently, the overload cutout, functioning as designed, trips to prevent overheating. Correcting this wiring error resolves the problem. It is also essential to consider the impact of sludge accumulation around the upper thermostat. Sludge acts as an insulator, preventing the thermostat from accurately sensing the water temperature. This leads to prolonged heating and eventual tripping of the overload cutout. In such cases, flushing the water heater to remove the sludge or replacing the thermostat may be necessary. Therefore, the key steps in troubleshooting a water heater with a popping overload cutout are firstly, checking the heating elements for proper resistance and shorts to ground. Secondly, verifying the correct operation of the thermostats. Thirdly, ensuring the wiring is correctly connected to the upper and lower elements. And fourthly, inspecting for and addressing any sludge built up around the thermostat. These steps provide a systematic approach to identify and resolve the underlying cause of the problem. The normal operation of a standard electric water heater involves a sequence of events controlled by thermostats and heating elements. Typically, there are two heating elements, an upper and a lower, each regulated by its own thermostat. The upper thermostat controls the upper element and has priority. When cold water enters the tank, the upper thermostat activates the upper element to heat the water in the upper portion of the tank. Once the water in the upper portion reaches the set temperature, the upper thermostat switches off and allows the lower thermostat to control the lower element. The lower thermostat then heats the water in the lower portion of the tank until it reaches its set temperature. This two-element system ensures a more even distribution of hot water throughout the tank. Several factors influence the efficiency and lifespan of a water heater. Firstly, water quality plays a crucial role. Hard water, rich in minerals like calcium and magnesium, can lead to scale buildup on the heating elements and tank walls. Scale reduces the efficiency of heat transfer and can eventually cause the elements to burn out. Secondly, the thermostat settings affect energy consumption and the risk of scalding. Setting the thermostat too high increases energy consumption and poses a scalding hazard. It is generally recommended to set the thermostat to 120 degrees Fahrenheit or lower. Thirdly, regular maintenance is essential for prolonging the life of a water heater. This includes flushing the tank annually to remove sediment, inspecting the anode rod for corrosion, and checking the temperature and pressure relief valve to ensure it is functioning properly. The anode rod is a sacrificial metal rod that attracts corrosive elements in the water, protecting the tank from rusting. It should be replaced every few years, depending on water quality. The temperature and pressure relief valve is a safety device that releases excess pressure or temperature to prevent the tank from exploding. It should be tested annually to ensure it is not stuck or corroded. When diagnosing water heater problems, it is important to use appropriate safety precautions. Always turn off the power to the water heater at the circuit breaker before performing any electrical tests or repairs. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. Never work on a water heater if you are not comfortable with electrical work. Consider hiring a qualified electrician or plumber to perform repairs. Electrical testing of water heater components typically involves using a multimeter to measure voltage, resistance, and continuity. Voltage measurements can be used to verify that power is reaching the heating elements and thermostats. Resistance measurements can be used to check the heating elements for shorts or open circuits. Continuity measurements can be used to check the thermostats and wiring for breaks or loose connections. When measuring resistance, it is important to disconnect the component from the power supply to avoid getting false readings. The proper resistance value for a heating element depends on its wattage and voltage. A typical 4500 watt 240 volt element will have a resistance of around 13 ohms. A shorted element will have a resistance close to 0 ohms, while an open element will have infinite resistance. Thermostats are typically tested by checking for continuity between the terminals when the thermostat is in the on position. When the thermostat is turned off, there should be no continuity between the terminals. A faulty thermostat may have no continuity in the on position or may not switch off when the temperature reaches the set point. Wiring connections should be checked for tightness and corrosion. Loose connections can cause voltage drops and overheating, while corroded connections can increase resistance and reduce current flow. It is important to use the correct size and type of wire for water heater circuits. The National Electrical Code (NEC) specifies the minimum wire size for different amperage ratings. For example, a 30 amp circuit requires at least 10 American wire gauge AWG copper wire. Overloading a circuit with undersized wire can cause the wire to overheat and potentially start a fire. Other common water heater problems include leaks, noisy operation, and discolored water. Leaks can occur at the tank, fittings, or relief valve. Noisy operation can be caused by sediment buildup in the tank or a faulty heating element. Discolored water can be caused by rust, corrosion, or bacteria in the water supply. When dealing with water heater leaks, it is important to identify the source of the leak before attempting any repairs. Leaks at the tank usually indicate that the tank is corroded and needs to be replaced. Leaks at the fittings can often be repaired by tightening the connections or replacing the fittings. Leaks at the relief valve may indicate that the valve is faulty or that the water pressure is too high. Noisy operation can often be resolved by flushing the tank to remove sediment. If the noise persists, the heating element may need to be replaced. Discolored water can be treated by flushing the tank and disinfecting the water supply. In some cases, it may be necessary to install a water filter or softener to improve water quality. Regular inspections and maintenance can help prevent many common water heater problems. It is recommended to inspect the water heater at least once a year for leaks, corrosion, and sediment buildup. The anode rod should be inspected every few years and replaced as needed. The temperature and pressure relief valve should be tested annually to ensure it is functioning properly. By following these maintenance tips, you can extend the life of your water heater and reduce the risk of costly repairs. In summary, troubleshooting water heaters involves a systematic approach to identify and resolve various issues. Understanding the common causes of problems, performing appropriate electrical tests, and following proper safety precautions are essential for successful repairs. Regular maintenance can help prevent many common problems and extend the life of your water heater. Always consult with a qualified electrician or plumber if you are not comfortable with electrical work or if you encounter complex problems. The principles of water heater operation and troubleshooting apply to both residential and commercial water heaters, although commercial units may be larger and more complex. Commercial water heaters often have multiple heating elements and thermostats, as well as additional safety features. The troubleshooting steps and maintenance procedures are generally the same, but commercial units may require specialized tools and knowledge. It is important to consult with a qualified technician when working on commercial water heaters. Newer water heater technologies include tankless water heaters and heat pump water heaters. Tankless water heaters heat water on demand, eliminating the need for a storage tank. They are more energy efficient than traditional tank water heaters, but they may require a larger electrical or gas supply. Heat pump water heaters use a heat pump to transfer heat from the air to the water, making them even more energy efficient than tankless water heaters. However, they are more expensive to purchase and install. Troubleshooting tankless water heaters and heat pump water heaters requires specialized knowledge and tools. It is important to consult with a qualified technician when working on these types of water heaters. The lifespan of a water heater depends on several factors, including water quality, usage patterns, and maintenance practices. A well-maintained water heater can last for 10 to 15 years, while a poorly maintained water heater may only last for 5 to 7 years. Replacing a water heater is a significant expense, so it is important to take steps to extend its lifespan. Regular maintenance, proper thermostat settings, and water quality treatment can all help to prolong the life of your water heater. When replacing a water heater, it is important to choose the right size and type for your needs. Consider the number of people in your household, your hot water usage patterns, and the available space for the water heater. Consult with a qualified plumber to determine the best option for your situation. Proper installation is also crucial for ensuring the safe and efficient operation of your new water heater. The installation should comply with all applicable building codes and regulations. In addition to electrical and plumbing connections, the installation may also involve venting and gas connections. It is important to hire a qualified plumber to perform the installation to ensure that it is done correctly. After installation, it is important to follow the manufacturer's instructions for operation and maintenance. This will help to extend the life of your water heater and prevent problems. In conclusion, water heater troubleshooting and maintenance are essential for ensuring the safe and efficient operation of your hot water system. By understanding the common causes of problems, performing appropriate tests, and following proper maintenance practices, you can extend the life of your water heater and reduce the risk of costly repairs. Remember to always consult with a qualified electrician or plumber if you are not comfortable with electrical work or if you encounter complex problems.